So going on here, I'm going to do some functions. All right, so this one's 25. So this one might not be that long since it's probably not going to be that long. I'll kind of go over the activity a little bit more. I know I made a video for it, but we'll get into that. So functions. And our goal for this one is, in this lesson, we will identify functions in multiple representations and relate to domain and range. So I know we're going to go into it, but just to give you guys a preview of what all of those words mean. Functions. So functions is this idea of, y equals something. It's this idea of you put in an x into a function and it's going to spit out a y. So a lot of times they compare it to a machine. You put in an x and you get out a y. So if you're thinking about something like temperature, temperature is what you want to get out of it. Sorry, that's our dependent variable. And it's going to be dependent on what? So depending on the time of day, you might get a different temperature. This function is what turns your time into temperature, basically. And when it's talking about domains and ranges, it's talking about all of the possible x values that turn into possible y values. So sometimes, if you watch the other video, sometimes that's continuous. I can't spell today, guys. I'm sorry. Continuous, meaning that there's going to be fractions and small fractions and stuff like that. Sometimes they're discrete, meaning that they're like whole numbers, or sometimes there's only half. Like, for example, shoe sizes. Shoe sizes are discrete. You're not like a size 2.3 or something. You're usually like a size 7 or a size 7.5. They're discrete. There's nothing in the middle here. Oh, no problem, Arthur. It's fine. If you wanted to answer the question for today is, what is your favorite movie? Or if that's too hard, what's the last movie you've seen? All right. So now we're going to be talking about a book sale. Why does it keep giving the answers? I want those later. Okay. So the city is having a book sale in the room it purchased, and the graph costs Y. So we're talking about dollars. Now, this is what's known as discrete because you can't sell half a book. It's discrete. So this isn't going to be like a continuous straight line. It's going to be a series of dots that kind of make up a line. So the blank depends on the blank. So in this case, we're talking about the cost. The cost of the books depends on the number of books we sell. So in this case, the cost of the books is Y because it depends on X, the number of books. At the sale, each book costs. So this will kind of be like our slope, our rate of change right here. It's going to be like, oh, okay, so what we can do is we can take how much it changes over certain things. So this is 1, 2, 3, 4. So if I look at this is kind of hard to tell how much each book is costing for one book. But what I can do is be like, well, two books cost $1. So if two books, always put your Y on the top. Y is how much it changes. This is known as delta. You guys don't really have to know about delta. It's just a symbol for change. So I'm just saying the change in Y divided by the change in X. I think Edmentum calls this Y2 minus Y1 over X2 minus X1. It's basically just your change. So your change is two books for every $1. Or since you want to do it in dollars, you're going to flip this over, which is $1 per two books. And this will reduce into 50 cents If you take $1, cut it in half, it's 50 cents. So that's 50 cents for every book. Oh, Joker was a good movie. I don't know if I'll watch it again though. And the people watching YouTube are going to be like, "What is he talking about right now?" Um, it was really good, but it like made me feel things. It made me feel uncomfortable. Not to say that's a bad thing. It's a good thing when art makes you feel things. All right. And and Endgame, I already talked about this. That movie made me tear up. I'm not gonna lie about that because I watched the original Iron Man like 3 times in theaters. So, relation. So a relation is just this idea that they're gonna relate to each other. There's something connecting these two, connecting the independent. What I mentioned before, independent um, is just something that we put into the machine that spits something out. It's in this case the books is independent because um, we don't know how many books are selling. We can't really control that. The price is dependent on how many books we sell. So again, we can't really control that either. But since we do price these out, it is going to affect the price. So that's why it's dependent. It's dependent on the number of books we sell. Um, a function, again, that's the relationship between these two. It's the relationship between the independent and the dependent variable. It's the relationship between x and y. So we're going to talk about what makes a function. In order for a function to exist, it can only have one y. So in other words, every x can only have one y. So it's usually seen like this. So you can have two x's be the same y. You just can't have one x have two y's. The reason for this is it's not a real relationship. Um, because if you're graphing this and you're like, oh, here's my x, and by the way, there's a point here and a point here, that's not a true relationship. It's not a true function because you shouldn't have two. A y can have two. So, for example, you can have something like, I'm trying to think. You can have something like this and like this. So, this y value has two x's. I guess I'll put numbers to make it less confusing. This one has two x's, one at 1, one at 5. So the way we would see this in a graph, there's this thing called a vertical line test. We're going to get into it later, but a vertical line test means if I draw a line, I shouldn't cross my graph. I have two graphs here, two functions. I shouldn't cross it more than once. So I'm only touching the yellow one time for every straight line I'm putting down. I'm only touching the green one time for every straight line I put down. In a map, this x should every x should only have one arrow. If you have an x with two arrows, it's not a function. On a table, you shouldn't have the numbers repeating. So there should only be a number once. You can have the y's repeat, but you can't have the x's repeat. Same thing when you're looking at a list of ordered pair. A list of points, you shouldn't have two x's. Every x should be different. And oops, let me go back to arrow mode. And this one's a little harder to see how we can do it. We would have to write it a little differently. These are just two completely different functions, but the way you would see a function is this is just showing the relationship. How do we get a y? Well, you have to take your x, multiply it by -2, and then we're going to add the 3. That's how you would show the relationship. And a verbal description, this one is just saying the output y is twice our input. So in other words, it's just saying y is equal to 2x. They're just saying it in words. Is this making sense so far, everyone? Yes, no? Everyone's thinking about their favorite movies right now? All right. So identifying a function. So identifying a function, that's this idea of figuring out what your domain and range are. Domain, again, is all of your x values. Your range is all of your y values. So domain, range. On the YouTube video, I kind of describe, you remember this because D comes before R and X comes before Y. And our relationship, in this case, since it's a straight line, this would be known as our slope. Our slope is what relates these two together. So here we're going to look at how to map. This one, like I said, isn't a function because we have two arrows in these x. Our x can only have one y. Normally they would show you numbers. I'm not sure why they're showing this, but they're just showing your domain can't have two different ranges. It can't have two different outputs. It has to have one output. Otherwise, it's not a relationship. And here's our vertical line test. So this one is literally just saying that you can't touch it twice. This is not a function because it touches the graph here and it touches it here. So let's identify these. So determine the relationship, click on it. So this one, every x has one y, so this is a function. This one would not be a function because this x has two y's. This 13 has two y's. If I look here, I have two negative x's, or I have two -2's as x's. So this -2 in both of these are repeating. So this is not a function. And it says it right here. This one, if we look at it, this would be a function because none of the x's are repeating. This one is a function because it passes the vertical line test. Not a function because it fails the vertical line test. So just a tip there. This is probably going to be a big part of your mastery test, is identifying functions. So let's do here. So we're going to say x is equal to x is equal to y squared. Is this a function? Y right now, according to the vertical line test. Did they give us a thing? They didn't give us a thing to graph. So here's a cool tool that I'm going to recommend you guys use a lot. It's called Desmos. This really helps when trying to understand any function, is you just kind of graph it in here. So we're going to do x equals y. And if you're having a hard time plugging in the squared, what actually is supposed to happen is there's a keyboard here. It's just my taskbar. I have it on auto hide, so it's hiding it. And I'm going to put the little squared button. If I need to put another exponent, I can use the AB button. I'm going to use the square. And this does not pass the vertical line test. It doesn't pass it a bunch of times, actually. You only need one example of it not passing it to work. This one has several examples. So when we're saying, is this a function according to the test? No, it is not a function because it fails the vertical line test a lot. You don't have to write the a lot part. But that's the basic idea. You can use that in your own words. So is this graph a vertical line test? Is there something I'm missing here? It's like, oh, use this slider, but oh, they did give us a graph. They just didn't make it obvious. So here's this. It's not passing the vertical line test a lot of times. Okay, that makes more sense. So I'm guessing that this one also has a graph. I just need to find it. Oh, there it is. So this, I'm going to make our line appear. It fails the vertical line test like throughout the entire graph. So this one is also not a function. Cut this, cut this. This is also not a function. It fails the vertical line test a lot. You can even say it always fails the vertical line test. Whatever you guys want to say in your own words, go for it. I'm just here kind of explaining it to you. So this graph, so we're going to look at this graph. We're going to do the vertical line test. Doesn't look like it crosses it twice. It's always crossing it once. So this is a function. This is a function. The graph only crosses a vertical line one at a time. And to kind of explain the vertical line test a little bit, think of it this way. This vertical line is all the values. Let me move it to 2. This vertical line contains all the y's that equal 2, right? So this is 2, 0. This is 2, 1, 2, 2. But they're all of these little dots where x is always equal to 2. So if it only crosses it once, that means that this x value only has one y value. So that's why the vertical line test works. Do we go to sign up? Sign up where, Alyssa? Did I miss something? I'm sorry, I don't understand your question. Oh, no. You don't need to sign up for Desmos. Um, sorry. Let me do this. I don't have one signed up. I literally just click graphing calculator. I know you can sign up. I just click graphing calculator and it lets you use it. Signing up is only in case you want to save like something, like let's say you wanted to save a specific graph. This is actually kind of useful because they have these pre-made graphs already and you can mess around with these. And like let's say you have an equation you're always using, you can save it on Desmos, but you don't have to sign up. And apparently you didn't even need it anyways because your thing had it. But if you do like using Desmos, I recommend it. I use it in the Algebra 2 class a lot. Yeah, Desmos is super helpful. All right, and then self-evaluation, just kind of describe how you did, what you liked. Like I would give myself a 4. I had no idea the graphs were provided. I should start doing this on my own account. That way I'm actually like if you ever look at my thing, it shows that I haven't done anything, even though I'm doing all of these with you, but I'm doing it from the teacher's perspective. So it always looks like I'm not doing anything. All right, so let's see. Oh, come on, Edmentum. And the tip, guys, sometimes I know it's not efficient, but sometimes you might want to click save and exit a lot just because Edmentum does get rid of your answers if you forget to submit and stuff, click submit before you hit save and exit. Because if you just click save and exit and you didn't submit it, it won't save your answers. So these are gone because I forgot to click submit. Um, Let's see. I can close this. Hopefully it'll load now. There we go. All right. So select the correct answers. We're looking for functions. So if I look here, 3, 4, 5, 6, this is a function because no repeats. This is a function. Whoa, this is not a function. This 2 has 2 arrows. That means this domain has 2 ranges. So not a function. If I look here, 10, 20, 20, 2 20s, not a function. This one, the way you can tell if this is a function or not is it's always y equals something. If you get something like y squared equals, all the changes should only be happening to x. So if there's changes happening to y, it's probably not a function. Or if you have something like this, plus or minus x, that means we have 2 x's, one that's positive and one that's negative. You'll see more examples of this as we get into further down algebra, but that's the main idea. This one's okay because all the changes are only happening to x. This one, if I'm looking at this, I'm like, okay, oh, cool. Let's pretend I know how to draw a straight line. I know that's hard to pretend, but let's pretend I can draw a straight line. If I could draw a straight line, this would pass all of it together. So this does pass the vertical line test. And temperature inside a classroom is recorded every hour. So in other words, the time is our input. So if you think about it, if we're measuring the temperature at like 9 o'clock, we shouldn't get 2 temperatures if we're talking about one spot. I mean, maybe we would get 2 if we're measuring inside a class and outside the class, but you shouldn't get 2 temperatures. So each time should have exactly 1 temperature. So that's how we get these. And even here, they drew a straight line. All right, so moving on. Domain and range. So domain, we have the discrete relationships, and we have, so discrete means dots, basically. So these relationships, it's discrete. You only have the specific domain. You only have these 3 numbers in your domain, and you only have these 3 numbers as your range. These are your outputs. So if you have 3 inputs, you should have 3 outputs. Unless there's repeating output. Sometimes your range can have less number than your domain because of repeats. I don't think we're going to be dealing with repeats right now, but there you go. The other type is continuous. When you have the straight line, usually when you're talking about continuous, you're talking about all the real numbers. So usually when we talk about continuous, we're going to be talking about these functions where x is all real numbers. Where this x value, we're going to talk about all x's. So what's our input? Every number on this. What's going to be our output? All the numbers going this way. Sometimes your output is limited. So for example, if I had this as my graph, my domain is only -4, everything greater than -4. My range would be right here at 3. My range, or a little bit before 3, it looks like. Everything bigger than 3. So there are going to be cases where it's not all real numbers for your domain and range, even if it's continuous. All right, so if we're doing this, we're going to plug these in, and we're going to plug it into this formula. So we're going to take this x, plug parentheses wherever we see an x, and we're going to solve for it. So this is going to give us our ordered pairs, our x comma y value. An ordered pair, I like to think of it as these are points. A point has two things. A point has an x and has a y. All right, so let's get into the questions. So here's our domain. Let's figure out our range. So I like doing these in a table. I'll just do my x table. This is going to be my output. And in this middle part, I'm just going to show my work. So if my x is -2, this would be 2 times -2 minus 5. So I'm going to do some mental math here. -2 times 2 is -4. So we have -4, take away 5. So we have 9 negatives overall. I like to think of this as you're drawing the negatives. How many negatives do we have? Well, none of them cancel out because they're all negatives. They would only cancel out if they were opposites, but they're all the same. So the next thing we're going to do is do it with 0. So 2 times 0, well, 2 times 0 is 0, take away 5. So 0 take away 5, that's -5. Then we're going to do it with a +2. So 2 times 2, that's 4. Then take away the 5, we're going to get -1. What's happening here is we have 4 positives, 5 negatives. Every positive cancels out with a negative. Every positive cancels out with a negative. And we're left with just that -1. Now we're going to do 4. Are the visuals helping, guys, showing these positive and negatives? Then 4 minus 5. Cool. Yeah, I like kind of showing the visuals just to kind of help you picture it in your head. So this is 2 times 4 is 8. Take away 5. I don't really want to draw all 8 positives, but you get the idea. 5 of these are going to cancel out with 5 of those positives. So you have more positives than negatives. So your answer is +3. So this is our output. -9, -5, -1, 3, which is the first one. Why isn't it the first one? Oh, there's a 0. Derp. I don't know why I read this wrong. I got a little backwards here. Wait, that's not it either. Let me try again. -9, -5, -1, 3. I was looking at this one, but I clicked on this one. That was my bad. Does that make sense? And then here they show all the work. All right. So here we're going to talk about the domain and range. So remember how I said all real numbers? So if we go all the way over here, there's a number in theory called -infinity. It's a theory. It can never be equal to. So it's x can be greater than -infinity. So x is greater than -infinity. Infinity. So the way we show that is our x value can be anywhere here, anywhere in the middle. So the way we show that in math is we put x in the middle. X has to be less than infinity because it can never be infinity. Infinity isn't a real number. And it's always bigger than -infinity. But this kind of lets us show that x is in the middle. X is in the middle of these two. Oops. X is in the middle of these two numbers. Our y values. Well, according to this, it looks like y goes all the way down to -infinity, and y is going to go all the way up to +infinity. So that means our range is all real numbers again. All the numbers between -infinity and all the numbers that are smaller than +infinity. So this is a tricky part because a lot of people think it's like, oh, it's equal to infinity. It can't be equal. Infinity is not a real number. It doesn't exist. It's the idea of as big as you can possibly get. So moving on here. So if I were to look at this, this starts and stops. So this starts right after -6. The reason I say it starts right after is it's an open circle. It does not include 6, but it could include -5.9999999. It could include that number, -5.9, because it's really close to 6, but it does not include 6. So we would say x is between -6 less than, but not equal to. It doesn't include it. This filled in circle says it does include it. So it is less than or equal to 9. Does that make sense what it means by having an open circle and having a closed circle? So an open circle means it includes it, or a closed circle means it includes it. Open, it's not there. It does not include that. That's for x. For y, if we're looking at the y values, nothing, nothing. Oh, when we get to 1, it's like, oh, cool. Y is in between 1 and all the way up to 6. So y is greater than or equal to 6. So y is in between 6 is the, or 1 is the smallest it can be. So y is bigger than 1, or it could be equal to 1, and it can go all the way up to 6, but not right at 6. And this is going to explain that. So, oops, I didn't mean to do that. I meant to click this one. So here it's saying all of our points, the smallest point and the biggest point, and it's showing the domain. Oops, what happened here? Oh, I clicked the wrong one again. So that's how it's showing us this. We're looking at the smallest y value. So when we're looking at range, we're looking at the y-axis. When we're looking at domain, we're looking at the x-axis. So even though the numbers seem a little backwards, it's based on what we're doing here. We don't care what order it's in. We're just trying to do this in a way that only talks about y and only talks about x. So we go left to right, down to up. All right, so the equation represent in this relationship is what? So the output is the difference. Okay, so the output. So y is our output. This is an equal sign. The difference is subtraction 3 times the input. So 3 times x and 5. So this is saying the difference between all of this and this. So that's how we kind of write this out. Our output is the y. Let me do that in a different color. Output is y. Is talking about this equal sign. Difference is talking about the subtraction. 3 times input, that's this. Specifically, the input is the x. And this 5 is just going to be what's left over. What goes on the other side of the difference. All right, so the equation that represents this is going to be y equals 3 times x. It's not 3 times y and x, because it's not saying, it's not 3 times the difference, it's the difference. So if it was 3 times the difference, then it would be that one. So these are really tricky. You kind of have to write it out how I did it. I did the subtraction sign first because it was the first thing mentioned, and then I put 3x on one side and 5 on the other side. So these, I'm not the biggest fan of how they word these, but Edmentum really wants you to do it. The relationship is, so this is a function because all the changes are happening to our input. The domain, So if the domain is bigger than x, okay? So if the domain is bigger than 2, so we're going to put 2 here, then, and this, we're just plugging it in just to say because it's going to be bigger than that. So this means that our y value has to be bigger than this 1. If we had it at 2, we got 1, so that means our y value has to be bigger than 1. Does that make sense? Everyone good? Cool. And then let me erase this. And then summary. So this unit ties in a lot with what I did in the last unit. So if you check out the video on graphing, yeah, I do talk about domain and range and continuous in that. So you can also watch that. I think I gave you guys more time because of the fact that it was on the day we didn't have planned. So be sure to watch it. And then also, we'll just talk about domain and ranges. One last thing, or I'll talk about that at the end, but let's kind of go into the activity in case you guys haven't done the activity yet. I want to talk about that. That way you guys get your unit 1 done. So going into the curriculum, if you guys are doing your activity, what I want you to do for these is you click on here to actually do your activity. When you're done with it, you're going to upload it. So you follow these directions right here. It says scan or take a picture. I like saving it to the Google Drive better than that. So follow these directions. The reason why I like doing it on the Google Drive better is you don't have to worry about pictures or anything unless you really want to worry about that. So what you would do here is you would click this use template button. You would write your name here. So my name is Victor. You would write your IS teacher name. So for example, if your teacher is Alicia, write Alicia. If your teacher is Anush, Miss Clara, write it there. And then for this, we're going to be talking about our shape. So this is like each size is named after a certain area. If you guys need help, they have little videos here. I also have a video on how to do this on YouTube. It's like one of the first videos that you'll see if you go to the playlist. But here's videos too on how they want you to do it. And then what I do here is if I want to show like an exact area, the tool you're going to be using is this. So here, you're just going to be using this tool. What is the length and width of this? Oh, so the length is X, and the width, if you double click this, you go here, so length times width. So that's what we're doing here, and you can take a picture with your phone, or I think there's a way to save the picture here. If you go to, someone showed me last time, and now I forgot how to do it. Oh, here you go. You can click save. This can save the picture, and then you can just paste it onto here. Oops, that's not it. What happened there? Click here to open save tool. Did it save it? Control C. There we go. And then any teacher can grab this, paste it onto here, and it'll show your exact image. So that's a good way to save it. Just don't forget to right click and copy. If you guys don't have, like, I use a snippet tool to copy and paste. But if you guys don't have access to that, so this makes my little picture. You can put a little picture like that too. Or if you're on a Chromebook, screenshot on Chrome. I'll show Mac too. Screenshot on Chromebook. If you're on a Chromebook, what you're going to do is you're just going to push. Why is this so complicated? You push Control Shift and hit this little screenshot button. Sometimes it works with just the screenshot button, so try it. But what you would do is push that button. I'm on a computer, so I just push print screen. And then you can paste it onto here. So if you hit that Chromebook button, you can do this. And mine's it's just showing both of my screens. Or Chromebook, it's that one button. On a Mac, where is it? Screenshot on Mac. On a Mac, you have to push Command, Shift, and 4. I don't know why it's like that. I don't know why Macs don't have screenshot buttons, but that's how you would do it. And screenshot on PC, which is what I use, it's literally this button that says print screen. It's just control? Oh, okay. So it's just control for a Chromebook. But you can always look up how to do it. Hopefully that helps. Did anyone have any questions about the? Let me turn off the recording.